Hello, let us look at Chapter 12, Review Questions. So they are about the angles in a circle. So for the first question, we have x given right over here. We need to figure out the value of that. Since it's an inscribed angle, what we have to do is, whatever we get, we have to divide that by 2. So then the measure of the arc that's opposing to that will be this. 360 minus 190 minus 120. Then we get to realize that 50 is the measure of arc that we see. So we have to get the half of that, which is 25. All right, let's move on to the next question. We need to figure out the measure of the arc over here. Since that angle is 50, another angle will be 40 here. So opposite of that has to be 80 degrees. All right. Let's look at the next one. So here we get, we need to figure out this arc, given that two chords are the same. So that means the other arc has to be equal to x as well. Now, since we have a 40-degree angle as an inscribed angle, its opposite intercepted arc would have been 80. So what we end up getting is 360 minus 80, and we get 280, and then we have to divide that by 2. We get 140 each. All right, let's move on to the next question. So here we have CB is equal to 10. That means arc AB must be equal to 20. Since the measure of the arc is same as a central angle, which is a value of x, so we get x equals 20. All right, that has been that bad. So let's move on to the next question. We realize that this is a cyclic quadrilateral. Since this measure of the angle, inscribed angle, is 120, opposite of that would have been 60. Why? Because in cyclic quadrilaterals, opposite angles are supplementary. All right, how about this one? That measure of the angle x that we see here, that is opposite of arc QR, and which is the same case for this angle 20 over here. So therefore x must be equal to 20 degrees. Alrighty, let's move on to the next one. Here we have number 29. Since we don't know the outer arc EC right over here, let's call that as y. So we get y minus 31 divided by 2 must be equal to 24. So that's how we figure out the angle intercepted formed by two secant lines. Then we get to realize that y minus 31 is equal to 48, hence y is equal to 79. Then to figure out the value of x, what we have to do is 2x plus 79 plus 31, because that inner arc right over there has to be equal to 360. Then we get 2x must be equal to 250. Therefore, value of x equals 125. Alrighty, let's move on to the next question. So we realize that we have two chords perpendicular to each other. Now, when you look at two intercepted arc, 2x and 150, we get to realize that since those two chords form 90-degree angle, when we add them up and divide that by 2, must be equal to 90. Then we get to realize that 2x has to be equal to 25, hence x must be equal to 12.5. Alright, how about the next one? Since we know that this measure of the arc is 61 and the other one is 133, so we can figure out the arc TS. If I call that as y, then we get 360 minus 133 and then minus 61. Then arc y becomes 166. Then value of x must be the difference of the arc, 166 and 61. Then we get 52.5 degrees. All right, let's move on to the next question. So since the angle formed by tangent is 45 degrees, then we get to realize that outer arc here, because inner arc is x, will be equal to 360 minus x. Now we apply the angle outer minus inner divided by 2 here. That should be equal to 45, which is the angle that's given here. Then we get 180 minus x must be equal to 45. Then x is equal to 135. Okay. And then that's it. How about next one? Number 43. I mean number E. JLI is 43 because that's given to us here. Now, then what's the measure of angle X? So then we realize that 43 is the angle formed by tangent and a chord. That will give us the same, which then arc JL would have been equal to 86, which tells us that angle K is also 43 as well. Then we can easily figure out the value of X from 180, subtracting 31 and 43. Then 106 becomes our answer. Alrighty. Now let's look at number 30. So here we have measure of the angle ACB. So I just drew the line over here. Is equal to 58 degrees. Now, notice that AC is a diameter, and then they also told us that BD and then CD is equal to each other. That means it's an isosceles triangle. So how do you find AB? AB is equal to 116. Why? Because it has to be double of the intercepted arc. I mean, double of the inscribed angle. So AB is equal to 116. And then that gives us BC would have been equal to 64. How do you find the angle BAC? There will be the half of 64, which will be 32 degrees. Now, how about DBC? DBC, you get to realize that angle A and angle D are the same angle because they share the same intercepted arc, which is 64-degree angle. That tells us that angle D is 32. So to find angle DBC, which is right over here, it will be simply 180 minus 32, which becomes 148. And we have to cut in halves because we have two angles here. So 74 degrees. That becomes our answer. Alrighty, let's move on to the next question here. Number 31. So we have points A, B, C, and D on the circle in that order. So we have AC and then BD meet at E, as you can see. Angle AB, arc AB is 34. And then CD is 102. And DA is equal to 109. And they want us to find angle BEC. Let's call that as X. So to find the measure of the angle Y, which is the angle DEC, which is the supplementary angle to X, all we have to do is adding up 34 and 102 divided by 2. Then we get to realize that it will be 68 degrees. Now, since Y is equal to 68, X must be the supplementary to that, which is 112. Now, let's look at number 32. Prove that if line M passes through point B on the circle O such that M is perpendicular to OB, then M must be tangent to the circle. Now, then OB must be radius here. So then, since they are perpendicular, I can draw many points from the radius to the other points along the circle, along that line that's perpendicular to the radius. Now, out of that, let's just assume one such triangle here. We get to realize that that's an right triangle. That side is the hypotenuse. That means that side has to be always greater than the radius, which radius in this case would have been this one. So all these sides are greater than the radius. But we know that the red one is the radius, meaning that's on the circle, while all the other points that we see has to be farther away from the circle. Therefore, it must be the outside point. In other words, there is only one such point. That will get us the intersection between the line and then the what we call it, circle. Since there's only one intersection, we call that tangent. And that's basically what we are saying. OC must be greater than OB. That means C is outside of the circle. Then there's only one point that's on the circle. So that's why we call that tangent. All right, let's move on to the next question. Use the knowledge about inscribed angle. Explain why the circumcenter of the obtuse triangle is outside of the triangle. So here we have two lines. Now, so about the red line, I can make two triangles, one with the blue and one with green. Now, in this case, center will be right around there. And you realize that obtuse in order for something to be an obtuse triangle, angle has to be greater than 90. But in a circle, using the inscribed angle idea, right angle will come if I have one of the side as diameter. Notice that the blue triangle, the angle that we see over here occupies the arc that's beyond half the circle because it has passed through the diameter. So then in that basically what that means is that this is the third side that we see has to be outside, meaning the center of the center of the circle has to be outside of the obtuse triangle. Now let's look at number 34. Point T is the minor arc of RS. So that means this is R, that's S. T is somewhere between R and S. Minor means smaller. So let's call that as T. Angle ROS is 53. So that means that's 53 degrees. They want us to find out the measure of the angle RTS. Knowing 53, we know that the opposing arc is also 53 as well. Then the other arc, the rest of them, will come out to be 307. And angle X is opposing to measure of arc 307. So X will be equal to 307 divided by 2. That becomes our answer. All right, number 35. KT meets T at Y. All right, and then we have 6 and 2 line segments here. Find the length of tangent. So what are we going to do? We're going to do tangent squared is equal to outside times the whole thing, which is equal to square root of 48, 4 square root of 3. Now, number 36. Point Y is on F, and X outside of circle F, such that XY is tangent to XF. Is the intersecting F at A and B. In this way. Now, since XA is less than XB, A is closer to X than B, and then YB is 134, that tells us that YA must be equal to 46 in terms of the arc. Alright, how about the angle XYF? That will be simply outer minus inner divided by 2, which will be equal to 44 degrees. Now, how about the measure of the angle XYA? That's 23. Why is that? Because it is the half of, between tangent and a chord, the measure of the angle is half of the intercepted arc, which is 43. So that's how we can figure out the 23 degrees. All right, let's move on to the next question. Number 37. So from the given picture, AT is 6, and then AB is 120. Find out OT. How do I find that out? So if I have to draw the line OT, we know that that line will cut 120 in halves, and then which creating 30, 60, 90 triangle. Since AT is equal to 6, then OA must be 6 divided by radical 3, which becomes 2 radical 3 when you simplify it. Then OT must be 4 radical 3. How about angle ATB? Because this is 90 and this is 90 and that was 120, we get to realize that that measure of the angle must be equal to 60, which is half of, and which is double of 30 anyway. And they want us to find the measure of the angle, measure of the area, OATB. So quadrilateral that goes around it. That's essentially double of the triangle that we see over here. To find the area of the triangle, we're gonna do 2 times 1/2 base, which is 2 radical 3, and then times 6. We get 12 radical 3 becomes the area of that quadrilateral. All right, let's move on to the next question. Number 38. In a circle, AB is parallel to CD. Okay, and then diameter is 36. What is the measure of the arc? AB. That's 50, and then the other one is 50 because all radii are congruent, which gives us triangle ABO to be the isosceles triangle. Then this vertex angle becomes 80, hence gives us the length of the arc AB is 80 out of 360 times 36 pi, because 36 pi is the circumference. So if you have to calculate this one, the answer becomes 8 pi. Alrighty. Let's look at the next question here. Number 39. So we have dodecagon. So I believe it's a 12 sides. Now, they want us to figure out, so imagine that's the dodecagon that we have over here. How would you figure out the measure of the angle ABC? Now, ABC would have been that portion of the angle. How much is it opposing? So we have 2 sides covering ABC, while 10 sides of dodecagon covering the rest of the circle. That basically means 10 out of 12 of 360. Then we get 300 is what we're looking for. Since it's 300, therefore angle ABC would have been 150, half of that. How about ACD? In case of ACD, we are looking at 9 out of 12. That's the intercepted arc. That's our opposing angle ACD, which gives us 270. So half of that becomes 135. Now ADJ, it's a 1 out of 12, which becomes 30 degrees. So it becomes 15 degree angle here. What is the acute angle measure between AF and then BI? So AF would have been that one. BI would have been that one. Then we get to see that AB must be 30 degrees, which is 1 out of 12. And then IF would have been equal to 90 because it covers a 3 size. Then obviously the angle will be sum between 30 and 90 divided by 2. We get 60-degree angle. That becomes our answer. Now number 40. Now given that VW Z is equal to 81, and then WZX is equal to 38. Now, how do you figure out VXZ? That's equal to 43. Why is that? We can easily see that from exterior angle of 81, which is sum of the two remote angles, which is 38, and then another angle, which now we know to be 43. Now, angle WYZ shares the same arc as the previous answer, which is 43-degree angle, so the answer must be the same, which is 43. How about angle XZY? Because you see the right triangle here in the middle, since one angle was 43, the other angle must be 47. They have to be complementary. And XYZ is in fact containing 43 and the small portion of the angle on top, which we now know that to be 38 as well, because they share the same arc as this angle. So when you add up 38 and then 43, we get to realize 81 as our answer. Now, how about WXY? WXY, which we are looking at the big angle. Now, WXY, it comes from the this triangle first. Since the bottom angles are 47 and then 81, 180 minus those two angles, 47 and 81, must give us 52. Actually, 52 would have been this portion of the angle, but they're looking for WXY, so we have to add 52 and then 43. So our final answer, in fact, becomes 43. 43 adding on to 52, so we get 95. That becomes our final answer. All right. Number 41. ABCD is a square with area of 100. And then we are looking at diagonal here, and then given in this way. So what they're looking for is to find the value, length of dx. Since area is 100, each side must be equal to 10, which gives us the diagonal, which is dB, is equal to 10 radical 2. While xy is equal to 10, why is that equal to 10? This xy is in fact same length as the length of one side of the square, because they are all diameters. Then to find dx, all we have to do is subtraction between 10 radical 2 and 10, and we have to divide each side by 2. And that becomes our answer. Alright, let's look at number 42. Z is 6 units from the tangent point. Y is 3 units away from the tangent point. And find YZ. Since Y is 3 units away, so the other one is 3 as well. Z is 6 units away, the other one is 6, so therefore YZ must be equal to 9. Simple as that. Not bad at all. Number 43. Prove that incircle of a given triangle is unique. Meaning, in order for us to prove that incircle is formed by angle bisectors. So if you can find only one intersection of the angle bisectors, then that proves that there's only one such incircle. So in any triangles, incircle basically means equidistance from all three sides. But to show the equidistance between two sides, we have to show the angle bisectors. So first line was the angles bisector between these two. Second one was for the green one. But as you can see, those two angle bisectors meet up only at one point. That's why there's only one such there's only one such point where it's equidistant from all three sides. That means we can only create one incircle. All right. Number 44. So here we have two circles tangent to each other, and then we have common tangent on PQ. We want to figure out the length of PQ, where AC, which is the radius of the small circle, is 3, and then big one is 8. First, I drew the line from the center to the tangent, P and Q. And then we draw another line this one is parallel to PQ, creating this one as a rectangle here. So long radius was 8 and small one was 3. That means that small portion is 3 as well. So this portion is equal to 5, while AB is equal to 11. And if I consider this one as x, that would be the value of PQ as well, because what we end up creating inside here is a rectangle. So x squared must be equal to 11 squared minus 5 squared. That means 121 minus 25. So x must be equal to square root of 96. That means 4 square root of 6. That becomes our answer. How about number 45? I have a hexagon, regular hexagon. So that I have one circle is inscribed, the other circle is circumscribed. I want you to find the area of the ratio of the areas between small to larger circle. I realized that I drew 2 radii, but between 2 radii, that triangle becomes 30, 60, 90. Because this is a 90-degree angle, as you can see, this will be 30-degree angle, because in a hexagon, central angle would have been 60, but half of that, therefore, becomes 30-degree angle. So we have 30, 60, 90 in the ratio of 1, radical 3, and 2. That means ratio of the radii are radical 3 and 2, but ratio of the areas are 3 to 4, therefore. That's it. Have a great day. I'll see you later.